Alright, so exercise 1C, I stopped at types. Thank you. Exercise 1C, I stopped at types of relations, and just to remind our crew as we move forward and recap on 1C and start on 1D before you go to the weekend, how many types of relations are there? Can you tell me, Adam? Yep, so how many are there?
One-to-one, one-to-many, many-to-one, many-to-many.
Many to many. So there are 4 different types of relations. Out of those 4 relations, which of those is a function? Can I have Layla? Good. As long as you have it something to 1, okay, it's always many x's to 1y or 1x to 1y, that is a function. Which one of those lines can you use? So you have a vertical line, you have a horizontal line test. Which one of those do you use to determine whether it is a function or not? Sebi? Vertical line. Why do you say that the vertical line is correct? How do I know? If I'm in a test and I'm sort of under the pressure, under the pump, how do I know that definitely the vertical line tells me whether it's a function or not? Can I please have Frank? How do I know? Just because I have a graph, let's say like that, and I do a vertical line test, what do I know? The vertical line test will tell me a function. How can I prove to myself? How do I remind myself that yes, that is a function? It will. Say it again. Cross the function. So, but just because it crossed once, why do we know it's a function? So why is it that if I did a square root relation and it crosses twice, why do we know that is not a function and that's a relation? How do we know? 2 y values. And that's the key thing. Remember, I want you to keep drilling in the idea that the definition of a function is that you only get 1 y value for every x. In this case, obviously, you put 1x and you get 2 y's. And that's why you know when you do the vertical line, it gives you 2 y values. And you can prove that to yourself. You're looking at it like, oh, actually, I got 2 y values. Clearly, it's not a function. So it really goes back to what is a function. If you understand what a function is, then it makes sense when you use a vertical line. And what does a horizontal line test do? Can I please have Quinn? What's a horizontal line test do? Say it again. Good. And so what is that? What's the point of doing it though? Why do I want to do a horizontal line test? Yes, you're right. It tells you for every x values how many, or for every y value how many x values there are. What's the point? So if I had a linear graph and I do a horizontal line test, cross once. If I did a parabola, cross twice. What's the point of knowing if it crossed once or crossed twice? If it crosses twice, what does it tell me? If it crosses once, what does it tell me? Why do I want to know? See, with the vertical line, you said if it crosses once, it's a function. If it crosses twice, you say it's a relation. So if I do a horizontal line test, it crosses once, what does that tell me? If it crosses twice, what does that tell me? Yeah, which is what your definition was. You said it tells you how many x's there are to every y. So why do you want to know that? Because you've got 4 different types of relation. If it crosses once, it tells you that for every x, you've got 1 y. If it crosses twice, it tells you that for every x, you've got many y's, many x's for the 1 y. Okay, so there's 2 x values, so you can prove it to yourself. You can say, oh, there's an x value here and an x value here. That's 2 x's for the 1 y. So this tells you, if you do a horizontal line test, it tells you whether it's a 1-to-1 or a many-to-1. Which, that's why you do the vertical line test first, and it tells you it's a function. You're like, okay, great, it's a function. Now what type of function is it? Do a horizontal line test, it tells you whether it's a 1-to-1 function or a many-to-1 function. Does that make sense? Yeah? Okay, so that recaps part of exercise 1C on what a function is. Now you're moving on to hybrid functions. Okay, there's 2 more parts of 1C. It's hybrid function, odd and even functions. Okay? Hybrid functions, you would have touched this last year, and it's not difficult. It's just, it's written ugly in a way that it looks difficult, and a lot of students find this hard, but technically this is one of the easier ones to do. Okay, so what I'm trying to do here is I just want you to understand, we've learnt everything for hybrid. We've learnt restriction of domain. Everything else is sketching straight lines. And remember I said the easier it is that you can visualize, the easier it is to answer the questions properly. If you can visualize this right now, it's real easy. But if I asked you right now, what is the domain and range from this, then it's kind of hard without being able to see it. So your job, for today's session anyway, I just want you to sketch it on a calculator. Sorry? Note 4, no, she's away today. Your goal is to, if you can do it by hand, do it by hand. It just takes a bit longer if you're doing 1C. What I want you to do is sketch the graphs, then interpret and answer the questions from that, okay? Obviously by mid-year I would, or even before your first SAC, I expect that you can draw all of it without a calculator. But for the sake of learning today's session, I want you to be able to visualize, interpret, okay? You have to eventually develop the skills to sketch every straight line and visualize them. So when I look at them, I look at the gradient, I'm saying, oh no, that's -1 between less than 0, and so I know less than 0 in my map, I've got something that's a negative gradient. This is a positive gradient from 0 to 1, so I'm like, okay, so that goes up, and then I've got another positive gradient, but it's less steep, and it's greater than 1. So in my head, already, well, that's right, I can't draw on this one. In my head, this is what I've got. I've got domain is less than 0, which is in this left-hand side, and I know it's a negative gradient, so it looks something like this. Okay, it goes all the way up until that point, and it doesn't include, so I have an open circle. Open circle, and then from 0 to 1, so in my domain I'd say, all right, 0, and that's 1. So from 0 to 1, I've got a 2x minus 1. This is a rough sketch, but in my head I've got a visualization of what it looks like. It might join here, it might not, but I know I've got a positive graph. And then from there it says greater than 1, okay, greater than 1. So notice this is equal to, so I've got equals to, I just don't know where the x and y intercepts are, I haven't calculated yet. But I got a visualization, it goes down, then goes up, but then I know this is another positive gradient, but it's a less steep gradient after 1. So if it's less steep, it might just look like that. Okay, roughly. I'm just guessing. Okay? What you're going to have to then do is to calculate each point or endpoints. So you've got to find out, all right, what's the x-intercept or y-intercept of this graph? So the x-intercept is when y is equal to 0, and you solve it, and that equals to, what is that, 0, 1, -1. So that means -1 x-intercept, y-intercept is -1, so I know here, it's -1, -1. If I had to calculate this one, the y-intercept is also at -1, so I now know, yes, it definitely crosses from here, and it goes up. So it starts at -1, and you're inclusive, and then the x-intercept for this one, if you solve for it, let y equal to 0, solve it, it's half, so I know that must be half, so I get a half. I need to know at 1, when x is 1, that becomes 2, 2 minus 1, that gives you 1, so I know right here I've got 1, 1. And then after that, I'm going to sketch this graph now from greater than 1. So if x was equal to 1, you've got half plus half, that's 1, which happens to be exactly at the same point. So I know it starts at the same point, and I sketch that. And so that's my hybrid function. That's me doing it by hand. Okay, but then that's what you're expected to do. Now it's not always going to be a straight line. It could be a quadratic. Normally it's a quadratic, and it could be a part of a cubic. It could be a sine graph as well, and it's just restricted. But you see what I'm doing is I'm breaking up the domain first. I hypothesize what each graph would roughly look like, and then I work out the endpoints to draw it accurately. Yeah? Yes, Josh?
Do you have to have a y value for every x equation to be a function?
Do you have to have a...
Would you have, like, for the second one, you have 0 less than x, less than
Yep. Yeah, and just on top of, in terms of just talking about notation as well, notice once I've put in equal signs, that I've said in this equation, when it equals to 0 or equals to 1, you do not do this, because that doesn't make sense. Because if you put an equal sign at 0, then do you use this equation? or do you use this equation, or do you use this equation? I know in this case it doesn't seem to matter. It does matter if the hybrid function is discontinuous, okay, meaning it doesn't connect well. All right, so if you ever, when you're defining in your SACs, it does matter if you're going to use the equal signs once, don't use it in the other ones, because it has to define it. You have to define it like, all right, 0, 1, inclusive, not inclusive 0, not inclusive 1, because these were inclusive already. Does that make sense? Yeah? Okay, so that's just notation. Now, just in terms of doing it on a calculator, which I'll show you later as well, how to do this on a calculator. I've done it on a calculator here. You can go back to this as well if you wish, but all I did was, I'm assuming in year 11 you learnt the define function. Yes, no? Yeah? I'm going to go through that later to make sure that you all know how to do it. I normally define each of the functions. So I define f of x, which is this one, define g of x, and then define h of x. I'm just doing this just to sketch it out for you. You can do it all in one go, and I'll sketch it for you. Okay? I'm just showing you, this is your graph with the given symbol tells you I've got a restriction x less than 0. So that's my first graph, f of x, and it stops here. If I didn't have the restriction, it'd carry on. Then I add in the second part, which is 0 to 1, and you've got a restriction given symbol, 0 to 1, and it sketches this red, which is exactly what I had before. I said it goes down, goes up, and the third one should be less steep than a red line. So if I do that, you can see it's less steep, and it carries on. Okay? Now, obviously, when you're doing this on a calculator, you can do all of this in one go by using that hybrid function that you have. You can have f of x equals, and you use the brackets, and you can enter 3 linear equations with 3 restrictions, and I'll show you that later, but I'm just trying to show you what I was doing mathematically by hand. Cool? So this is hybrid function. One of the things you're going to need to be able to do is, one, you need to be able to read it and sketch it, and then the second part is you need to be able to read the graph and write it. Okay, so there's sort of back and forths here. Now, most students will get better at this, but not many students are good at reading this and writing out the notation. So I've got a separate PowerPoint with 4 different questions, and what I want you to do is I'm going to give you the graph. Your job is to write it in terms of this. Okay, so let's look at the layout before we start. Let's look at the layout. So we have f of x, which is the function, whatever the function is, it could be g of x, h of x, doesn't matter, equals 2, and you're always going to use these braces to determine how many hybrid functions you have in there. It could be a quadratic, could be whatever it is. Okay? I'm going to give you this, but I want you to get the correct domains. Okay? I want you to list out the correct domains for them. All right? And each one, this tells you the domain for the first function, this is the second domain for the third function, and on so forth. Now, the one thing I want you to make sure as is when you're writing out the restrictions, you can either go from bottom to up or up to down, from top to bottom. Okay, so what I mean by that is, notice it went from 0, so less than 0, to 0 to 1, to greater than 1. Or you can do it from here. You can go from less than 0 to 0 to 1 and greater than 1. It has to be in order though. So it's either going from small to largest or largest to smallest. You do not do a mumble jumble of them. So I can't put, let's say, x less than 0 here, and then 0 to 1, and then greater than 1. Like, I mean, it does work. It's just conventionally that's not how we write it. Okay, so it still works. It's just conventionally that's not how we write it. We always write it in ascending order or descending order. Cool? All right, so what I want to do in the next slide, next PowerPoint, is I'm going to give you a couple graphs, and what I want you to do is write out the domains and restrictions. You've got to pay attention to, do you include or do you not include? Okay, so if you've forgotten how to not include, if I had a graph, for example, that went down and it had a closed circle, that means include. Okay, if it doesn't, I'll have an open circle. Okay, you're going to list the domain and range just as you would now. Easy? All right. To odd and even functions, and that concludes 1C, and hopefully if we have a bit of time at the end of the session, I want to do, where is it again? There we go. Hybrid function, and here we go. These are the functions. This is the graph. Your job you're going to determine which one of these represent. Actually, is that the one I just did? That's the one I just did. All right, let's move on. There you go. I've given you the equations. You determine which one of these is the equation based on the steepness, based on the gradient, whether it's positive or negative. You determine which one of the equation it is. And I want you then tell me what is my hybrid function. So learn to write the notation for it. Okay? So look at the graph, look at the domain, look at where it intersects. I want you to write the equation and its corresponding domain based on the graph. Okay? Let's have a go with that. There's another 3. So this one's 1, you got another 2. All right, let's see. Let's see if you got this correct. Now, it so happens that it's all in its order because that's a negative gradient. The only out of these 3, that's the only one with a negative gradient. So you got to know that this is negative 2x minus 2. This is a higher gradient or steeper gradient than it is for the gradient of this. This has 1. So I know this is 3 and that's 1. So therefore, 3 is the one that's steeper. And out of these 2, which one's steeper? Clearly, this one's steeper. So I'm going to write this as 3x minus 6. And this is 1x minus 2. Okay, so that means if I'm going to move from left to right in terms of my order, I'm going to say, all right, so it's either less than 0. So the domain, always start with the domain. So you're saying, all right, domain, whoops. Domain is x less than, or you could say, it's up to you whether you want to put the equal signs here or not. Okay, if you're going to copy the format as before, then it's less than 0. For what function? I've got negative 2x minus 2. Then, after I've defined that less than 0 is this graph, then this graph here, 1x minus 2, is between 0 to 2. Okay, so 0 to 2, you can sketch this graph, 1x minus 2. So I'm going to say, all right, 0 to 2, and now, since I didn't include 0 before, I'm going to include 0 here. I'm going to say, all right, let's include it. Now, it's up to me whether I want to include the 2 here. I probably choose not to if I don't want to, and I can include it in the other graph if I want to. Okay, that's perfectly fine. Nothing wrong with that. So I can now say this is 1x minus 2. Remember the comma. And then I go into the next one. So after 2, so x is greater than or equal to 2, because I did not put equals to 2 here. And then my graph would be 3x minus 6. So 3x minus 6. Put it all together. Voila, that's my hybrid function. Hands up if you got that correct. Fantastic. Any questions? Yes? On any of them, but you only put it once. You do not put it twice. It will become more prevalent or more obvious when you don't have a continuous function. Right now it's continuous, so it kind of doesn't matter. It does matter when it's separate. And then you've got to look at the dots, whether it's open circle or closed circle, then it matters. Okay? Let's try another one. Let's try this one. So this is discontinuous, so it does matter whether you include or you don't include. All right, let's have a look. So I've listed the equation. Hopefully you picked up what I was saying. Horizontal line, clearly -4. So that has to be horizontal. Negative gradient, positive gradient. So it's pretty straightforward. I always like to start off with the domains because the domains makes it easier to just write it all correctly. So I'll start off with this one. This is not including a -4. And it's going to infinity, so negative infinity. So I will start off by saying x is less than -4, and because it's not including, I don't put equals to. The next one was from -4 to 0, so -4 to 0 is on my x-axis here. That's including and including. So I'm like, all right, 0 equals to, oops, not 0, the other way. -4 to 0, but I'm inclusive. Then I look at this one, and I'm like, okay, that's not inclusive at 0, but all the way up to 2, I am inclusive. So not inclusive at 0, but inclusive at 2. So once I've got the domains correct, I already knew which functions it is, so you just simply write it all in. You're like -4, negative x plus 5, and 2x plus 6. Use your braces, equals to f of x, and that's your hybrid function. Okay, so you see what I'm doing? The hardest part is just reading that correctly. And when you're reading that, just make sure to pay attention of the dots. Because those are the marks that you normally lose in your exams when you're doing differentiation and whatnot. You sketch it. That's the only part that most students do wrong. Okay, and remember, once you use an equal sign, you don't use it again. Okay, it doesn't make sense if you use it twice. Then you don't know which one you choose. Okay? All right, I think I've got one more example. Yeah, okay, there we go. Let's try this one. All right. Check your answers. Remember, whether it's ascending or descending doesn't matter. As long as you've got the correct domain with correct function, then you're all good. Correct domain, correct function. Have a look. Make sure the symbols are correct. Actually, whether you only use one equal signs or not. Okay? Because in this case, it doesn't matter. It's continuous. So you could put equal signs here, equal signs there. It's up to you. All right? Hands up if you got that correct. Perfect. Good. So there you go. That's how you write hybrid functions. In case it was only mentioned because last year's group had a lot of difficulty writing hybrid functions, so we made sure you guys can do that now. Now let's go to today's session again. Is it? Oh, right. Last part of today's session for C. Odd and even functions. Copy this down. Odd and even functions are defined by the order of the polynomials, meaning the power of the functions. Okay, so you can tell whether it's odd or even. Now, there are subtle differences between the two. So x squared, we say that it's an even function because it's symmetrical. So we would quickly sketch that. This is an x squared, and it's symmetrical on both sides, a lot about the x equals 0 line. As the cubic, it is technically symmetrical, but it's asymmetrical in the sense it's a reflection in both x and y axes. Okay? And it's still at the x equals 0. But this is an odd function, and that's an even function. The nice thing to know about them is just when you're doing application questions, they won't tell you it's an even function, but if you notice that it's a power of 2 or power of 4, or you know that it is even function, sometimes they'll give you one coordinate, or if it's an application question, it might just be the height of the fence. And that should be enough for you to figure out the rest. It's subtle hints for you to pick up. That's the only reason why you need to know it. Otherwise, most cases, you don't really see the use for odd and even functions. It's just in a couple of exam questions, once or twice out of how many years they've been, they've subtly put it in. So that's just something to notice. Now, it's not the fact that it's odd-powered or even-powered. It's based on this definition, which this is the mathematical definition of what an odd function is and what an even function is. Now, at first it looks weird, but if I explain it, it totally makes sense of what it's trying to say. What it's trying to say is if you want to know if it's an odd function or an even function, you test it. How do you test it? If you sub in a negative number, so that's why they said negative x, okay, so your pre-image is the negative x. If your image, okay, so the result comes out as negative of your original function, okay, so negative, which is a reflection of your original function, it is an odd function. Whereas if you sub in a negative value and it still is the same function as it was before, then that's even. A typical example is, let's take these, take these two, for example. You see, if I had f of x, my original function is x squared, then I'm going to test it now. So what's my test? I'm going to go, all right, let's test this concept. I'm going to say, let's sub negative x in. If I sub a negative x into this equation, and the equation ends up being exactly the same, it's even. If I sub negative x in, and it ends up being a negative of this graph, meaning I get negative x squared, then that is an odd function. If I don't get either, then it's called neither. Okay, it's neither an odd or an even function. So if I test that, I sub, all right, let's sub negative x into this equation. So I sub negative x in, and it just so happens if I square negative x, that gives me x squared. So therefore, what I'm saying is negative f of negative x is actually equivalent to f of x, because f of x is x squared. So if this equation is equivalent to this equation, then by definition, it is an even function. Okay? And that's the same with odd. Now, I know this looks pretty straightforward. It's the next few questions that will be different. So this is your questionnaire textbook. And some of them, just because you have an odd or an even, you don't know whether it is an odd or an even or neither. So the only way to figure that out is if you use the mathematical test, sub in the negative x to see. Okay? Now, as you sub it in, you'll probably pick up there's a hint or a pattern to it, and you'll figure it out. Every time there's an odd power, obviously it's going to end up being a negative. Okay, so if it's x to the power 3, then if you sub a negative x in, it's going to be negative. So obviously this one, I straight off the bat know it's going to be even. Because if I sub negative x in, it's still going to be positive. If I sub negative x in, it's still going to be positive, so this equation hasn't changed. So that's an even. This one is an even, because it hasn't changed. Okay, it's when you have an odd power that you've got to watch out. And especially when you have a mix of odd and even powers, that you just got to think, is it going to change the equation or is it not? Okay, so what I want you to quickly do is just figure out for me, let's do E and F and tell me what the answers are for them. So I'm just doing the first one so you can see still equals to f of x. So therefore, it is an even function. Okay, watch over go at E and F. And that concludes 1C, and I'm going to get you to practice on 1C before, if we have a bit of time, I'll talk about 1D, otherwise I'll leave it to next session. Okay? But we're a bit tight in term 1 just because there's so many interruptions, and especially because we have a double on Tuesday, the parent-teachers knocks out 3 lessons that I could potentially have with you this term, technically 4 in total, because parent takes 2, and then the next day is a late start, so you lose another session with me on a 3. So one of these few sessions I'm going to have to squeeze in a couple of exercises. Means that you have to keep up with me. Okay? Much time. Have we got the answers for E and F? This is the proper way, if the question ever comes up in exam, rarely, but if it does, that's the proper way to write your solutions. How I do it in my head is I look at E, and the first thing I look at is just the powers of each of the x's. So clearly right now I've got 1 on x to the power of 1 minus 3. All I'm asking myself is, that became a negative, odd powers make it a negative. So in my head, I already know it looks like this. And I'm like, well, is that the same as saying multiply this by -1? And it's not. Okay, because if I multiply by -1, you're going to have the negative x but a positive 3. Okay, so that's why I know this is neither even, because it's not the same, and neither is it odd, because if it was odd, it should have been -x plus 3. So this is a neither. Okay? Whereas F, see what I do with F is I just literally look at the powers. I look at the powers, there's a power of 1, so I'm like, okay, that's going to be a negative, negative, negative. So in my head I'm like, okay, that's negative x5, negative x cubed, negative x. Then I ask myself, all right, well, if I multiplied all this by -1, does it give me this? Because if it does, it's odd. If it doesn't, it's neither. Because this clearly does not look like the original function. My question is it the negative of the original function? And it happens to be. So -1 times this gives you that. -1 times x cubed gives you negative x cubed. And -1 times x does give you negative x. So this is clearly odd. Does that make sense now? Yeah? So you don't have to do it this way. This is the proper way when you're doing your SACs and you're doing your sort of exams. But just for your understanding, that's what I do. Okay? Yes? That concludes 1C, and we've only got a couple of minutes. So I'm going to let you have a go with a couple of the hybrid questions. I'm going to put up the questions up here, and I want you to have a look at them and have a go. Okay? Please download this PowerPoint. Download this PowerPoint and have a go with these questions, the 5-minute questions here. See what you understand, recap what you remember, domain, range, how many types of relations, What is a function? How do you test it? Okay, just keep that in mind. You've got to know those key factors, right? These are the questions. Just have a go with a few, and then we'll call it a session, and then on Monday I'll try to pick up 1D and 1E. Yes, Queen. Alright, Year 12s, I know you enjoy my lessons, but the bell's just about to go, so you can pack up. Make sure to practice, gotta keep up. We're gonna lose the low sessions this term.